Hello everyone. Today I'm going to discuss the second problem of Leetcode Weekly Contest 436, which is assign elements to groups with constants. So what is the problem? We are given an integer array groups where group size represent the size of the ith group. You are also given an integer array elements. Your task is to assign one element to each group based on the following rules. So what are the rules? An element j can be assigned to a group I if group size is divisible by element j, and if there are multiple elements you have to take the smallest index j. If no element satisfies the condition, you have to assign -1. Okay, so let's take one example. This first example only. So let's take this. Uh, Let me write it here. Okay, okay. So this is the first example. So how we are going to solve this? That is not the first question. The first question is what will be the answer for this example. Okay, so we have to assign each element. Um, we have to assign one element to each group. Okay, so for 8, okay, for 8, what is the minimum index such that 8 is divisible by elements j? Okay, what is the minimum index such that 8 is divisible by elements j? That is the first index, zeroth index, you can say. So answer will be uh, 0 for the 0 for the first element, first group. For 4, what is the minimum index j such that 4 is divisible by element j? That will be 0th index only. Now for 3, what is the minimum index such that 3 is divisible by 11j? There is no such index. There is no such index, so the answer will be -1 here. For 2, what is the minimum index such that 2 is divisible by 11j? That is the first index or second element. Okay, so this will be 1. For the last, the index will be 0. So answer will be 0, 0, -1, 1, 0. So answer is 0, 0, -1, 1 and 0. Now, how we are going to solve this problem? So for solving this problem, the brute force way to solve this problem is to, for every index for every index go to each and every element and find the first element which divides the current group I. Okay, so for every group I, just iterate over the elements array and find the first find the first element which sorry, find the first element which divides the group I. Okay, so what is the worst case time complexity for this approach? The worst case time complexity for this approach will be, let's say there are no elements which divides each and every element of the group. Let's say our group array is like 1 1 1 1 1. Okay, 1 1 1 1 1, and our elements array is 4 2 only. Okay, for 4 2 only. So for each group I, we'll just iterate over the entire element size. So let's say the size of this is n and size of this is m, then overall time complexity will be order of n into m. So our brute force solution has worst case time complexity of order of n m. So let's look at the constants now. So n is nothing but group's length, which is 10 to the power 5, and m is nothing but the element's length, which is also 10 to the power 5. So overall time complexity will be order of around 10 to the power 10, which is not possible. So we have to think something better. Now how we can think some better solution? Okay, now for any problem involving devices, okay, for any problem involving devices, we have to think about one time complexity, which is square root of n. How? So we can, for every element we can determine, let's say for every element n, we can determine all of its devices in root of n time complexity. Okay, so root of n time complexity. Okay, so what is the maximum value of ai here? The maximum value of ai here is also 10 to the power 5. So our overall time complexity is on the order of n root n. Okay, so we can solve this problem by finding all the devices of group I. We'll solve this problem by finding all the devices of group I and mapping it to them. Okay, so how will we solve this problem in order of n root n? That is the question. So let's come to our solution approach. Okay, so we'll maintain one map. Okay, so map of I will denote the minimum index. So let me write it in the text format. So what map of I will denote? So let me increase the font to 28. So map of I will denote minimum index in elements of minimum index in elements where elements j equals to I. Okay, So elements of j equals to I, we have to find the minimum index that mi will denote. So mi will denote the minimum index in elements where elements j equals to I. Okay, I hope you get it. So after we find this mi array, after we build this mi array, how we are going to approach this what I'm doing. So we'll iterate over groups I. We'll iterate over all the elements in the groups. Okay, and we'll find all the devices of groups. So we'll find all the devices of group I. So d1, d2, d1, d2. Let's say till dr. Let's say dr. Okay. So r could be at max square root of group size. The r could be at max square root of group size. Now among these values, we will find the minimum value of di. So we will find minimum value of dr. Okay, from d1 to r, we will find the minimum value of d of 1 to r. Okay, that will be our desired answer for this. So let's jump into the code. You will understand it better. Now I think you got why minimum of all the devices will give us our answer I. Okay, I hope you get it, because mi is nothing but minimum index in elements where elements equals to I, and we are finding all the devices of groups I and find the m value of that device. Okay, so let's come to the solution. So we are initializing answer with -1. Now this part is populating the mi array. So here our d is nothing but the map. Okay, m map. Okay, so d of bi equals to I plus 1. Now here comes one interesting case. When we are populating the value, we have to consider, let's say we have something like 133, right? 133. So we have already mapped m of 3 to the first index. Okay, 0 1 2, this is the index 0 1 2 if we use zero based indexing. So we have already mapped 3 to 1, right? So whenever we are trying to map this, we have to check that if the value is non-zero, or you can say that m dot instead of d of bi equals to 0, you can count bi also in the d. So here you can also do d dot count bi equals to 0. Okay. Okay, you can write it this way also. Okay, now we are again iterating over every element in the groups. Now this part is for finding all the devices. This part is quite straightforward and quite well known also, how we found devices in an array. You can search it in Google Geeks for Geeks also, that how to find all the devices of an element in root n. Okay, so we just iterate while j into j is less than equals to ai. So all the devices less than equal to square root of ai will iterate. Now if j divides the current group size, okay, now we have to consider two elements. One is j and another one is ai by j. Okay, now dv is ai by j. Now if dj is greater than 0, we can do d dot count j also. If dj is greater than 0, we'll just do mini equals to min of mini comma dj, and similarly we'll do for another divisor also, which is ai by j. At the end, if mini we have initialized mini with m plus 1. If mini is not equals to m plus 1, we just set answer I as mini minus 1. Here you can see that we used one based indexing here, because we are using dj. Now if we use zero based indexing, then our dj could be 0 in some cases. That's why we used one based indexing, and at the end we are just doing converting the one based index to zero based index. I hope you get it. If you have any doubt in any part of the code or explanation, please write in the comment section. I'll try to reply each and every comment. Also, if you find this video helpful, please like the video and subscribe to the channel, and also share among your peers. Thank you.